A missile is fired at an upward angle out of a window in a tall vertical building. See diagram. So here's our tall vertical building. This is the ground, and this is the missile being fired. The window is 30 meters above horizontal ground. So this is where the window is, and it's 30 meters above the ground. The height of the missile above the ground h meters, t seconds after being thrown, is given by the formula h equals 30 plus 25t minus 5t squared. Part 1. Describe the shape of the graph of height versus time. Give a reason. Part 2. By constructing a table of values, sketch the graph for t is greater or equal to 0 or less than or equal to 6. Part 3. Estimate the greatest height of the missile and the time at which this occurs. Check your estimate by completing the square. Part 4. Use mathematical tools, table, graph and algebra to determine the time at which the missile hits the ground. Part 5. If, instead of hitting the ground, the missile hits a target which is at a height of 20 meters above the horizontal ground, use your table, your graph and algebra to estimate the time at which the target is hit. Part 6. By finding the change in height in 1 second, find an estimate for the speed of the missile after 5 seconds. So, part 1. Describe the shape of the graph of height versus time. Give a reason. The shape of the graph will be N-shaped, quadratic. This is because h is a quadratic expression in t. So that means we have a t squared, so it's quadratic. And the coefficient of t squared is negative. So we have minus 5t squared, which means we're going to have an N-shaped graph. Part 2. By constructing a table of values, sketch the graph for t is greater or equal to 0, less than or equal to 6. So we're going to start off by substituting 0 into our formula, so swapping both t values for 0 with brackets around it, and we'll end up with 30. Then we're going to substitute 1 into our formula, and we'll get 50. Then we're going to substitute 2 into our formula, we'll get 60. Then we'll substitute 3 into our formula, we'll get 60 again. Subbing in 4 gives us 50, subbing in 5 gives us 30, subbing in 6 gives us 0. So then we're going to plot our points. Our first coordinate is 0, 30. So we go to 0 on the x-axis and 30 on the y-axis and plot our point. Then we have 150, so we go to 1 on our x-axis and 50 on our y-axis, and we plot our point right there. Then we have 260, so we go to 2 on the x-axis, 60 on the y-axis, and we plot our point. Then we go to 360, so 3 on the x-axis, 60 on the y-axis, and we plot our point. Then we go to 450, so 4 on the x-axis, 50 on the y-axis, plot our point. Then 530, so 530 is going to be right here. And then 60 is going to be right here. Then when we have our coordinates plotted, we join them together to form a curve, making sure that the top of the curve is an actual curve and not a line straight across. So it has to be a smooth curve, and we must draw this with a pencil. So this is the graph of h equals 30 plus 25t minus 5t squared. So it's an N-shaped graph. Part 3. Estimate the greatest height of the missile and the time at which this occurs. So the greatest height will be the maximum turning point. Check your estimate by completing the square. So from the graph, the greatest height, the greatest value of h, is about 62 meters and occurs after 2.5 seconds. So if we have a look at our graph, this is the maximum turning point. And if we move over to our y-axis, it's around 62 meters, and it happens at 2.5 seconds. So 2.5 seconds and 62 meters approximately. This could also have been estimated from the table, but the greatest height not as accurately. By completing the square, we start off with our equation, so we have h equals 30 plus 25t minus 5t squared. Well, the first thing we have to do is change this to a positive. We have to have positive t squared. So h becomes minus h, 30 becomes minus 30, minus 5t squared becomes 5t squared, and plus 25t becomes minus 25t. And we arrange it so we have t squared, the t, and the constant. So all we did there was change the signs and rearrange our terms. Next, we're going to divide across by 5, because we don't want 5t squared, we just want t squared. So 5t squared divided by 5 is going to be t squared. Minus 25t divided by 5 is going to be minus 5t. And minus 30 divided by 5 is going to be minus 6. And minus h divided by 5 becomes minus a fifth h. So we've just brought the minus h over the other side, and now it's minus a fifth h. We've just swapped these around. So no signs need to change in this step. Next, we're going to bring the constant over to the right hand side. The constant is minus 6, and it comes over and becomes plus 6. So we still have the t squared, we still have the minus 5t, and the minus a fifth h is still on the right hand side, and now the minus 6 comes over and becomes plus 6. Next, we have to halve the coefficient of t, and the coefficient of t is minus 5. So minus 5 divided by 2 is going to be minus 5 over 2. And then what we're going to do is we're going to square that. And we're going to add it to both sides of the equals. So we have minus 5 over 2 in brackets squared added to the left of the equal sign. And we have minus 5 over 2 in brackets squared added to the right of the equal sign. They must be in brackets or it'll be incorrect. So now we have t squared minus 5t plus minus 5 over 2 squared equals minus a fifth h plus 6 plus minus 5 over 2 squared. So next what we're going to do is factorize our t squared minus 5t plus minus 5 over 2 squared. So I've written it out over here. So since we have a t squared, we know we're going to have a t in the front of both brackets. Since this is a plus, we know these signs are going to be the same. Since this is a minus, they're both going to be minus. And then we need to take factors of minus 5 over 2 squared. So factors of minus 5 over 2 squared are just going to be minus 5 over 2 and minus 5 over 2. And minus 5 over 2 plus minus 5 over 2 give us minus 5. And t minus 5 over 2 multiplied by t minus 5 over 2 is a perfect square, so it can be simplified to t minus 5 over 2 squared. So that's where the t minus 5 over 2 squared comes from here. So we factorized this and we ended up with this. So then we have minus a fifth h, we just bring that down, and then 6 plus minus 5 over 2 squared gives us 49 over 4. Okay, so in the next step we have brought minus a fifth h over the equal sign to become plus a fifth h. We've kept the 49 over 4 on the same side, but we've just changed it to a decimal, so it changes to 12.25. And then we've brought the t minus 5 over 2 squared over the other side, and it becomes minus t minus 5 over 2 squared. But we've just changed the 5 over 2 to 2.5, so we've changed it to a decimal. So minus a fifth h came over the equal sign, became plus a fifth h. 49 over 4 stayed where it was, but just changed to a decimal, 12.25. And t minus 5 over 2 squared came over the other side to become a minus, and we just changed the 5 over 2 to 2.5. So now we have a fifth h, but what we want is h. So in order to change that to h, we have to multiply it by 5. So we're going to have to multiply across by 5. Everything needs to be multiplied by 5. So a fifth h multiplied by 5 is just going to be h. 12.25 multiplied by 5 is 61.25. And minus t minus 2.5 squared multiplied by 5 is going to be minus 5 times t minus 2.5 squared. So, the greatest value of h will occur when the perfect square is 0, i.e. when t minus 2.5 is equal to 0, or t is equal to 2.5. For this value of t, h is going to be equal to 61.25, and so the exact greatest height is 61.25 meters. And we can clearly see from our graph that our maximum turning point is indeed 61.25.